So good afternoon to our session, Einstein Platform Services Overview. Our start will be really easy, and it's late in the afternoon, so I want to have a bit of exercise for you all. Everyone raise his or her hands who is seeing a banana over here. Who is seeing a shelf? Or maybe a table? How many bananas are on this picture? You have 3 seconds to decide. Too fast? OK. Who can see? So what does this sentence mean? Can I change my credit card? Right? Quite easy. So let's see how fast you can find similar patterns of can I change my credit card in this text. 1, 2, 3. Done. How many? 4, 1. So, and this is the first key takeaway. Einstein Platform Services helps you to automate processes. Processes that rely with vision, means images, or with text. Finding text elements and classify them. My name is René Winkelmeier. I work as a developer evangelist with Salesforce. I focus on Einstein, on enterprise architecture, mobile, and a couple of other things. So what you will learn in this session is, first, some basics to understand what is our offering around Einstein Platform Services. And second, you will see it in action. Who in the audience is a developer? Raise your hands, please. A couple. So rest assured, you will see code, right? Just saying. It won't be death by PowerPoint. Our services, Einstein Platform Services, have 2 brands. First, we have vision. Vision includes everything around image classification and object detection. So what does it mean, image classification? You take an image and you classify it as a category. I always take my kids as an example. I have 3 kids under 5. Yes, it's busy, right? So it's really busy with them. And every day I have to explain them something. This is a banana, this is a car, this is a policeman, right? So they learn by seeing something. And I categorize that for them for the first time. And they have to learn by themselves. Sometimes they're getting it wrong, right? So I have to correct it. And you can apply a similar thing to image classification. You train Einstein Platform Services with a specific set of data, a category of images, and it can then automatically apply this pattern to images it has never seen before. Object detection is something that we released quite recently. As beta currently, everyone can use that, and it allows you to detect a pattern of an object, for example, within an image. We use this in retail industry, for example, where field people take a picture of a shelf, and we automatically can detect where in the shelf is product A, B, and C, so that you know is a product in there, and you can count it. The second offering is Einstein Platform Language. Language allows you to pass in a specific text, and you get either back the sentiment, so is the text good, positive, neutral, like is someone posting something on Twitter about your company, which is in a positive way or in a bad way. And the second thing is intent, which is really interesting, which allows you, like, can I change my credit card, to automatically classify what category of text does this belong to. And you can then use it, for example, to route a request to a specific agent with Service Cloud. So Einstein Platform is not built into Salesforce, right? It's not part of the core product, but it is an API. So you can use this from everywhere, either using Apex, Node.js, Java, Python, Go, you name it as a language, which also gives you a bunch of opportunities to use that, for example, in native applications, also on platform, wherever you want. The thing is, there are 45 API endpoints. Who loves to explore them all? Raise your hand. 2. So whoever wrote a decent or wrapper around a decent SDK like here, you know what time it will take to dig through all that. So luckily, we got you covered, at least for the Einstein, for Salesforce platform, because we have a wrapper library. And you will see that later in action. So let's talk a bit about the basics that are the same in Einstein language and in Einstein vision. So here we have our famous banana. And first, you have to classify your data. So let's take this example. You would feed Einstein Platform to learn and to identify images that contain a banana. It could also be a machine, or a product, or a damaged car. So first, you have to define the category. This is a banana, or a shelf, or is it a bowl with fruit? So it all depends on what you feed in Einstein Platform. We call that an example. And you give this example a label, a category, right? So at the end, when you predict what this image is, Einstein will give you back the label that you trained up front. First thing to know. The second thing is to know it's not sufficient to just only feed one image, right? Because pattern detection needs more data. We enforce currently, I think, for image classification, minimum 20 images. Depending on what you want to predict, you may have to feed 500 images, an example from different angles. So this is basically a collection of examples. And a collection of examples is what we call a data set. So why is this important? Because the data set, with all their examples, is the source that you can then take to predict an image or a text against. And you will see later what it means if you try to predict something where you haven't trained Einstein with. So based on a data set, you get a model. So let's take this example. You have your data set with bananas, with oranges, and with cars, whatever your label is. Then you take the data set and you hit train. An Einstein Platform takes your data with your labels, learns those patterns, and creates, based out of that, a model. And the model is then later used to be the source of prediction. So what does prediction mean? Prediction means you take an image or a text, run that against your model, and you will get a list of labels, of your trained labels, and their probability, a value between 0% and 100% if the pattern that you trained, or that Einstein trained, matches. So you want to see it in action, right? I think that's the first, most important part. We have an open source offering which you can just deploy into a Salesforce CX scratch of your choice, into a sandbox, and maybe also in a production environment where you can get hands-on without writing a single line of code on your own. No worries, all developers, you can change it if you want, right? You can write your own code. It will make it really easily. But this playground gives you a very first head start. So what I did here, no, that's too big. What I did here is I trained a model, and this is a standard data set that we offer on Einstein.ai, where we have 50 images of mountains and 49 images of beaches, and trained Einstein to identify this. So as soon as I throw in an image, it will give me, based on the trained model, a prediction with how many percent the image is a beach or a mountain. So just let's try it. I'm going to prediction. I select my model, and this is a model ID where I run the prediction against. I'm going to take a not random file. I'm just taking my banana, right? So remember, we have a data set that has two labels in it, beaches and mountains. That's what Einstein learned. Now I'm running a prediction against that with a banana. Will that work? No? See some shaking heads? Well, somehow it works, right? Einstein thinks, hey, with 67%, this is a mountain. And why does it happen? Because it only learned those two labels, right? So let's go back and take a pre-built classifier, a pre-built data set that we offer. Hang on. OK, shouldn't take a too large file for this. And this pre-built classifier knows what bananas are, right? And with 86%, Einstein is now sure that this is a banana. So the lesson learned here is, and this is really important when you start working with any AI, that it's not also only about the data that you train, but also the data that someone wants to predict that you haven't trained. Because if you would have relied on that, an example in an automated process, your process would likely kick off and say, oh, it's a banana with 60%, I'm fine with it, and proceed in the process, right? So when you start using any AI, and all that relies to Einstein Platform Services, you also have to be sure that people will feed in something that you don't know, or that where the pattern hasn't been correctly applied. The second service is object detection. So what I did here is something that you shouldn't do in real life. I trained Einstein with only 7 examples for the label of Astro and Cody. So I took the bear and Astro on the floor at home, took a couple of pictures, and trained it. It succeeded. And Einstein object detection now is able to detect, hopefully detect, Astro in this image. So let's see. It takes a bit longer than just image classification, because the service has to check pixel to pixel to pixel across the whole image if there is a pattern that's known. And it's live code, so I have an error that occurred. That's awesome. Let's try it a second time. If you want to blame someone for the non-working code, that's me, by the way, because I wrote the playground. That doesn't seem to go along. I just proceed to the next demo, just to be sure. So let's take sentiment. Prediction. Prediction of sentiment means we have a text. You're taking a given text, like, for example, a Twitter feed, or text that someone sent you in an email, in a service case, for example. And you want to detect, is this customer happy or not happy? So with this pre-built community sentiment that you, for example, can use in your Q&A system within Community Cloud, you can identify, is something going on where a service agent has to get in? So I am in a good mood, which is likely, with a failing demo, not true. And here you can see that I'm now getting back 53% negative and 46% positive. Would you think the model is good enough for being trained? Right. And this is another lesson that you should be aware of when working with AI. You start by training a data set, and you have to test the outcome. So what we are doing is, when you, for example, feed 100 images, we are taking 90% of those images for the real training and 10% of the images for testing the training and giving you a training accuracy. And you have to validate that, because it's an ongoing process. People in the field that will use for the image classification, object detection, or in example sentiment, will have, like with spam mails, false positives. Something will happen where the pattern that you try to detect hasn't been trained, or hasn't been trained correctly. So in this case, the outcome is likely not that good. The other thing is to use Einstein language intent. And here we have a model basically a list of sentences classified per category, where now Einstein learns the sentences, and based on the sentences, it's automatically able to identify similar patterns, like in a service chat, like in an email, like, where's my credit card? Can I change my credit card? My credit card has been lost. Can I change my password? All those kinds of Q&As. And let's see what I'm now getting in my prediction. Can I change my credit card, say? So in this part, it gave me the category billing. So based on the training where I can change my credit card, it gave me the billing probability back. And this is then also really important to understand based on the probabilities that you got back. Because we trained Einstein in this simple example with 5 categories, and it gave me the category billing back. So based on the pattern that I had, it gave me billing with a probability of 0.99 back. Someone told me this is less than 1%. So for all developers, it's a float number, right? So just multiply it with 100, and you get the real percentage. So whatever Einstein gives you back is a list of all your labels with a probability of where it assigns. So where can you use it? For example, in service case routing, which is really popular. Next best action, for example. But what is now your task when working in code with you? So whoever wrote a decent API or really worked with all this, it is huge. You have around 20 parameters that you can set, a lot of return values, and we decided some time ago to free you from this because it's currently not built in Salesforce. So everything you see in the playground is part of a wrapper library, which is open source, available just to include in any org. And to make this even easier, because you saw the playground, you saw what it took to predict, for example, an image. And we're just making that a bit bigger. Predicting the intent is technically 2 lines of code if you want to get started with Einstein Platform Services. If you want to train a data set, for an example, upload a zip file that contains all your images, it's 2 lines of code. If you want to include it in Process Builder, for example, it's 5 lines of code, right? Where you just start with the Einstein prediction service over here. You instantiate a new service. You're getting the result of predict image URL. In this case, we had a field that contained a publicly accessible URL of an image in it, in the account object. So once the account object gets saved, the prediction runs, classifies that image, and stores the label of the highest probability in the account field, which is a really good example. So a customer of ours is using this. They have people in the field who are reading electric meters, right? So go from household to household and check that. And those people also are checking the cable condition, right? Good condition of the cables, should the meter be replaced? But they are no experts. So what the company did is they took hundreds of pictures of good condition, average condition, bad condition, and now those people only take a picture when they're reading the electric meter, and depending on the automated classification, they are scheduling a replacement of the meter, for example. Which then means, and this is a perfect use case, that wherever in your business a human has to make a decision based on what she or he sees, could be a use case for Einstein Platform Services. And the same applies to where someone has to make a decision on scale based on text. I have 10 minutes left. Questions right now or afterwards?
This Apex library, how do you get started?
So the question is, how are you getting started with Apex library? This is I haven't paid him for this, but you can go on Trailhead for our trail mix that we have for AI, everything around Einstein. And the second link links you directly to the GitHub repo for the open source SDK that includes everything around language and vision. Any more questions? So the question is how it is different from Prediction.io. Prediction.io is an open source library where you really have to build your own patterns using, well, you have to apply your, right, you can't do it in Apex, right? It's not an API. You have to feed your, you work with Spark ML and with Scala, where you really have to develop this. Here we are offering a service where you only have to upload your data, and we are doing all the heavy lifting of pattern definition of machine learning for you.
Various templates like the text search templates.
Exactly.
So right now here it's a vision and only the text search. These are the 2 templates.
Exactly. So yes, so the question was, the point was Prediction.io offers templates for various services. We have now a specific set for language and vision. Yesterday on the developer keynote, we also announced that we will have named entity recognition, like number, date, cities, names, and so forth soon next year. Awesome. More questions? They will kick me out soon because I'm over time, but who cares?
Specific use case that recently, where we had some login issues, and then they have opened hundreds of cases. Can we look for specific words in the cases that open in the service cloud, and then predict how many cases are related to this issue, like single sign-on login or authentication fail, and then pull those cases out from the mix of all the support cases? Is there something you can do with this?
Yes.
How do you feed the case data? How do you train the data?
So the question is, can I use that service to identify pattern, in example, in a feed case? Yes, you can. Yes, you can. And based on the probability, then issue another action on that. Okay. Thank you very much.